Hi, I'm Ms. McHale. Okay, so we're doing the Calvin cycle. We're going to start with the first step, which is carbon fixation. So we've got 3 molecules of something called RUBP, and RUBP is a 5-carbon molecule. We've got 3 of them. Okay, we've also got 3 carbon dioxide right there, and a molecule, or rather an enzyme called rubicose, is going to swoop in, and it's going to break the carbon dioxide apart. Okay, it's going to break the carbon dioxide apart, and it's going to supply an extra carbon from the carbon dioxide to each molecule of RUBP, which, as you recall, is 5 carbon apiece. So we're going to be given a 6 carbon to each RUBP molecule. Once they've got 6 carbons apiece, the rubicose actually goes ahead and splits them. Okay, splits them, so that we end up with 6 molecules. Okay, of 3 carbon each. These molecules are called G3P, and we've got 6 of them now, okay? So we're working with our G3P. Now we're in the second step. Now we're in reduction. Now for reduction, what's going to happen is each G3P molecule is going to come along, and NADH is going to approach it. ATP is going to come in, and it's going to release energy so that the NADH can give its hydrogen molecule to the G3P, okay? So that's going to continue to happen to each of the 6 G3P molecules, okay? NADH, ATP, ATP releases energy, the NADH gives its hydrogen to the G3P, and that's going to go ahead for each one of these, all right? Each one. And now what we've got is 1, 2, 3, 4, 5, 6 molecules of no longer G3P, but now called triose phosphate because it's got all that extra hydrogen. That makes it into a sugar. So we have triose phosphate, and we've got 6 of them. So now we're going to move on to regeneration, and what happens is one of the triose phosphate gets put aside, while the other ones, the other 5, move on. And what happens is I believe it takes 2 ATP, 3 ATP actually are going to come along, and they're going to provide enough energy for these triose phosphates to rearrange themselves, okay? They're going to rearrange themselves in such a way that what we have in the end is, wait for it, you'll see, 5, 5, and 5. We're back to 3 molecules of RUBP. We've got 3 molecules of RUBP, which are going to go back to the carbon fixation step, and we're going to do the whole cycle one more time. Yes, we are. We are going to do one more turn of the Calvin cycle, and the reason we want to do another turn is because, if you recall, we put one of the triose phosphate aside to make glucose, okay? And that one we'll need 2 triose phosphate to get the 6 carbon we need to make glucose, because if you recall, that's how it works. So, real quick, we're going to run through it just a second time, just to show you. We've got our 3 RUBP 5 carbon molecules. Rubicose is going to come. It's going to split the 3 carbon dioxide molecules. Okay, it's going to split them. It's going to remove the oxygen, and it's going to provide an extra 6th carbon to each of the RUBP molecules. And then each of the RUBP molecules that has a 6th carbon is going to be split by rubicose. Okay, and that's going to give us 6 different G3P molecules at the end of carbon fixation. Now we're on to reduction, where an ATP molecule and an NADH molecule are going to meet up. The ATP is going to provide energy for the NADH to give its hydrogen to the G3P, which turns it into triose phosphate. So that's going to happen 6 times. 6 NADH are going to give hydrogen, 6 ATP molecules to provide energy, until we have, in the end, exactly what it is that we're looking for, which is 6 molecules of the triose phosphate. That's what we want. And with this second turn of the Calvin cycle, we now put another triose phosphate aside to go with the first. These 5 go through regeneration, where they zoom on up here. Okay. These 5 are going to be rearranged using 3 ATP molecules. They're going to be rearranged into 3 more molecules of RUBP.
Hey there. What did you say that the ATP was used for in between carbon fixation?
3 more molecules of RUBP, 5 carbons apiece. Okay. And those go back to the carbon fixation step to do the whole cycle again. But now that we've done a second turn of the Calvin cycle, these 2 triose phosphate that we set aside the last 2 times are going to be able to come together to form a molecule of glucose. And that's really what we're looking to do here with the Calvin cycle, is to create glucose. So that's the whole process.